David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember you can adjust the playback speed to make it faster or slower as you like. Second, you can pause the video at any point to catch up on your notes or jot down some questions. Third, you can turn on the captions so you can read my words on the screen. Today's topic covers simple and compound interest. So let's get started. Simple interest is interest paid on principal only. So if you invest $5,000 or put it in a savings account, it's going to give you some interest every year, which you get. It goes in your account. But the next time they calculate the interest earned, they're only going to calculate that interest based on your original deposit, that $5,000. So you're making money, your account grows every year, but your interest is only earned on your initial amount. So let's do an example with that. Action. Today's topic is simple and compound interest. So let's take a look at simple interest first. Simple interest is a situation where you put money, say, in a savings account, and it earns a certain percentage interest for you every year. At the end of the year, they put that interest in your account. So now that's your money. But when they go to the next year to calculate what you make, they're only going to calculate that interest based on your original investment, that original $5,000. Even though you have some interest from the previous year sitting in the account with it, it doesn't earn you interest. So that's simple interest. Now, simple interest makes an arithmetic series, and we're going to take a look at that in just a minute. Let's take a look at an example. Let's say you put $5,000 in a savings account. It's earning 2.5% simple interest. How much do you have after 3 years? So pause the video. If you know how to do that calculation, go ahead and do that. All right, let's see how you did. I just did this in a step-by-step method without a formula. So at the end of my first year, I have 5,000 plus 5,000 times 2.5%, which is 0.025. So I end up with 5125. At the end of the second year, the calculation happens the same, except I'm just starting with what I had at the last year. So now I have 5125 plus this same term, and that gives me 5,250. And then finally, for the third year, I end up with $5,375. That's simple interest. Now, what I'd like you to do is write a formula that allows you to calculate this with one step. All right, so here's what I get. Here's my initial amount, 5,000, and I'm just going to add 3 of these terms. 2.5% of 5,000, that's our 125, and I'm going to multiply that by 3 to get my total. So now what I'd like you to do is generalize this formula. I'd like you to write a formula that would calculate this for any amount, any interest rate, any number of years. Now think real hard, try that, and then come back. Okay, let's see how you did. I brought that last step up from our previous board. So we had 5,000 plus 5,000 times our interest rate times however many years, which in our case was 3. And that's what we used. Now, I'm generalizing here. Actually, first I want to factor. I've got a 5,000 in both of these terms. So I factor the 5,000 out. I leave a 1. That's a placeholder to get this 5,000 when I distribute. And then I have my 0.025 times 3, which is what's left in there. Now I'm going to take this form and generalize it. So my final amount, A, is going to be my principal amount, that's my P, times 1 plus the number of years and the interest rate. I just switched those around. So here is our simple interest formula right there. You can use this to plug in any simple interest calculation that you see. Let's look at compound interest. Compound interest is paid on principal and on interest. So unlike in our previous example, let's say at the end of the first year, now you have $5,125 in the account. Now the interest for the second year is going to be paid on that increased amount. So for the second year, the interest you earned during the first year earns you interest. So you start earning interest on your interest. So as you might expect, that account is going to grow faster and it's going to make a geometric sequence. And you're happy about that. And that's indeed how banks do it with compound interest. So let's do an example. $5,000 in a savings account for 3 years at 2.5%. Go ahead, pause the video and do that calculation. All right, let's see how you did. I just did this calculation in the same way we did the last one. So I have 5,000 plus 5,000 times 2.5% interest. So at the end of the first year, it's the same. I have $5,125. But now for the second year, I'm starting with 5,125, and I'm going to add 5,125 times 2.5%. And so now I'm creeping up. I'm making a little bit more money by the end of the second year. And similarly, on the third year, I start with my second year amount in these spots, multiply through, and now I have $5,384.46. So you can see this is growing faster, and it is a geometric sequence. So now I'd like you to pause the video and see if you could take this all the way through to a general formula for that situation. All right, let's see how you did. So here is our first year calculation, just 5,000 times plus 5,000 times 2.5%. So I factor my 5,000 out and I get 1 plus 2.5%. Combine those terms because they're just numbers. So the first year calculation is 5,000 times 1.025. Now, pause the video and do the second year calculation. All right, so check this out. I just threw another 1.025 onto the end of my calc, and here's how that works. Here's how much after the first year. This much is going to get multiplied by our interest rate multiplier to get the second year. So there's my second year calculation. So hopefully you're seeing the pattern here. What I'd like you to do is write the third year calc in the simplest form. So here it is. We just multiply our initial amount by 1.025 3 times to get the end of the third year. So now you can see how this is a geometric sequence. We've got a power that's expressing repeated multiplication in this case. So now what I'd like you to do is pause the video and write a general formula that will allow you to calculate the amount in account after a certain number of years with a certain interest rate with a certain starting amount. All right, so here it is. It's just your ending amount is going to be your starting amount times 1 plus your interest rate in a decimal raised to the power of n years. So this gets you compound interest with yearly compounding. Now, in reality, banks do compounding much more frequently. So let's take a look at that. All right, so let's take a look at monthly compounding. So what we're going to do here is we're just going to divide our yearly rate by 12 to get our monthly rate. But then we're going to do that 12 times each year. So we put our 12 up here and multiply that by our years. So this would be monthly compounding. Pretty straightforward. Now, what I'd like you to do is write one for yearly compounding. All right, using a 365-day year, we divide R by 365 to get the daily interest rate, and then we multiply the number of years by 365 to capture all the periods of compounding. So now, pause the video and write a general formula. All right, I introduced the variable k. If you went for that, you might have used any other variable, but this is what our textbook uses, so we should stick to that. So we just have the amount equals the principal times 1 plus r over k. K is the number of compounding periods in 1 year, so 1 plus r over k to the kn. So this is your compound interest formula for calculating the amount in an account. Okay, let's do some examples. But before we start, I want to remind you that pay attention to your prompts because there's different calcs for simple interest versus compound interest. So pay attention to that. And then some of the more complicated problems will actually have you compare both scenarios and see how much more you make or how much more you pay with compound interest. So check this out. This example, $35,000 is borrowed at 4% for 5 years simple interest. How much is repaid? So in other words, we borrow this money for 4 years, we pay 4% simple interest. How much are we going to pay back? So go ahead, pause the video and see what you get for that. All right, I just used our simple interest formula. That's the initial amount times 1 plus the number of years times the rate. So I did my number crunching here. Oh, forgot a parenthesis. Put that in there. I get 1.2 times 35,000 or $42,000 is paid back. Here's an example that might be close to real life or certainly might be possible for you. $10,000 put in a savings account at 3.5% interest for 25 years compounded daily. So this is a scenario, like sometimes people come into money or maybe their parents give them money upon graduation. So this $10,000, let's pretend you got that and you just throw it into account and pretend like you don't have it for 25 years. Just leave it alone, don't touch it, and then come back 25 years later. So you're going to calculate that right now. Go ahead, pause the video and find out how much you have. All right, I grabbed my formula here with my k's in there for my compound interest formula. Then I did a straight up plug-in step where I put my amount, I put my 1 plus my yearly interest rate divided by the compounding periods per year, and then this is times the number of years times the number of times compounded in each year. So go ahead, if you haven't already, crunch those numbers and find out just how much money you have. All right, check this out. Starting with $10,000, come back 25 years later, now you have $23,987. Not bad. And guess what? You got this extra $13,000, almost $14,000 for no work. It was just money sitting there working for you. This is a great way to build wealth. All right, let's do a borrowing example. $12,090 borrowed for tuition. This loan gets paid back in 2 years. It has some monthly payment. It gets paid back in a total of 2 years. If the total of those payments was $16,000, let's find the interest rate. Now this might seem a little confusing at first, but just check it out. You've got all the information you need. Pull out that compounding interest equation formula and do a plug-in step on that. All right, so the trick to realize is that this is like a savings account in reverse. You are given money and you're paying interest on that money as you pay it off. So your starting amount is the amount that you borrowed, and then your ending amount is the amount that you paid off. So we started with this, it starts earning interest rate in this term of our formula, and it's going to end up making $16,000. The way to think about this is that the bank is treating you like a savings account. So check this out. This term here is 1 plus my rate over 12. We don't know rate, but we know the number of terms is 12 because it's monthly compounding. And then this is 24 because we're 2 years at monthly compounding. So that's 2 times 12. So this gets us our equation. Now, we need to do a few things. I'm going to see how far can you take this. Let's go ahead and try to solve that for R. All right, let's see how you finish this up. So what I did, I'm ultimately trying to get into my R here, but it's buried. It's in this term, it's raised to a power, and it's multiplied by that. So the first thing I did is I divided that away, dividing both sides. I get 1.32 equals this term with the 24th power. Now, to get the power off, I just take the 24th root of each side. So I moved this over. I got 1 plus R over 12 is the 24th root of 1.32, which that gives us 1.01174. I'm carrying a bunch of decimals because I want to do my rounding step at the very end. So check this out. Now I just subtract 1 from each side to get R over 12 alone, and that gave me 0.01174. Then I multiply by 12 to get this 12 off from underneath the R, and I get R equals 0.14092. Now as an interest rate, if it's asking you for an interest rate, you want to use the right units. So I move my decimal places over, and I get 14.1%. One last example. So check this one out. Bank account has $900 in it now. 1.5% interest compounded quarterly has been paid for 6 years. What was the initial deposit? So sometimes these IB type questions are complicated in that it's hard to figure out exactly what's going on. So let's look at that again. I'm going to rephrase this. 6 years ago, we put some money in an account. For 6 years, it paid 1.5% interest compounded quarterly. Now the account has $900. What was that starting amount that got us here? Now, compounding quarterly means 4 times a year. So that gives you another piece of information you need. So go ahead and do your plug-in step on your equation and come back. All right, so here's the plug-in step. This is our ending amount. Here's what we don't know. That's the starting amount. Here is our interest exponential term. 1 plus the rate as a decimal, don't forget to do that, divided by the number of times compounding per year, quarterly is 4, and then raised to the power of the number of times compounding by the number of years. So that's 4 times 6 years, so that's the 24th power. So now, pause the video, pull out your calculator, and solve for P. All right, so here we go. Now, this time I'm not going to need to take a wild root because everything in this part of my expression is known. So I just simplified on down. My interest rate divided by 4 plus 1 gives me this term here, 1.00375. Raising that to the 24th power is going to give me 1.09399 times P. Now dividing through by that term, I get P is 822.68. So what that means is we put 822 in an account for 6 years, it earned 1.5% interest compounded quarterly, and it wound up giving us back $900. Now that you've watched the video, take a moment to jot down any additional notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.